Hey guys, welcome to this tutorial about Kubernetes on Azure. The goal of this video is to demonstrate how to deploy a basic website on Azure using Kubernetes and configure autoscaling. Now, who is this video for? This video is for people who already have a basic understanding of Azure, Kubernetes, Docker, and who want to learn how to deploy a containerized website or application using Kubernetes and configure autoscaling. Why would you use Kubernetes? Well, with Kubernetes, you can easily apply updates to your application or website without any downtime. So your application is always available to your customers. It is cost effective because you can automatically increase computing power when you need it and scale down when you don't need it. So you don't have to pay for resources you don't need. It is self-healing. That means that if a container goes down due to a hardware or software failure, the Kubernetes system ensures that it is replaced in time to help maintain the capacity and bandwidth of the system. Load balancing. Kubernetes also comes in with a built-in load balancer to distribute your load across multiple pods, enabling you to rebalance resources quickly in order to respond to batch processing, peak traffic, or incidental traffic. To outline this, we created an example website called Gimax. This is about a business that has been established in Amsterdam and is now expanding to different parts of the world, such as the US, Asia, and Africa. And now the business needs to make sure that it can handle the new visitors and the extra traffic. For that, normal hosting is not going to cut it anymore, so we need to move to the cloud, which we are going to do using Azure and scale up using Kubernetes. Now let's take a look at some crucial components in the Kubernetes ecosystem. First, we have nodes. Nodes can be either physical or virtual machines on your cluster. These machines are necessary to run your application containers, including the container runtime and other critical services. Pods. Now, a pod is essentially the smallest deployable unit of your Kubernetes ecosystem. More accurately, it is the smallest object. A pod specifically represents a group of one or more containers running together in your cluster. Load balancer. The load balancer acts as an intermediary between the end users and the pods. This happens through the load balancer's external IP address. So end users can send requests to this external IP address, and then the load balancer forwards these to the correct pod in the cluster. The load balancer also divides the traffic amongst the different pods and nodes in the cluster. Now that we've taken a look at the crucial components, let's dive into the demo. So in your browser, you go to portal.azure.com, assuming you already have a Microsoft Azure account. Now we are going to create a new resource. We do that by clicking Create Resource on the left. And then we want to search for Kubernetes Service. Then we click Kubernetes Service and we click Create. Now we are going to create a new resource group. We call it Gimax-RG, but you can use or call it whatever you want. We press OK. Now we are going to give the cluster a name. We call ours Gimax. For region, we select West Europe because that's where we are located. But you can choose whichever is closer to you. Now we are going to change the node size. Here we want a VM, let's choose a VM that meets our needs. Because we are on a limited plan, we are going to choose the cheapest option. We are going for the B2S, which is about 30 euros. This should be enough for a basic website, but you can choose whichever virtual machine meets your needs. and is available in your subscription, of course. So we press select. Now we are going to choose the scaling method. We may have to make sure it is on auto scale, otherwise it will not auto scale. And we put the node count range on 2 because we are limited by our plan, but you can insert a number that's supported by your plan and meets your needs, of course. We go to the next step to see the node pools. Here we don't change anything. We leave the settings on the default. Make sure you have the same settings. On the authentication tab, we also leave the default settings. On the networking tab, we also do not change any of the settings. Make sure you have the same. In the integrations, we leave on the defaults as well. And the tags, we leave like that, but you can add tags if you want to. And then we go to the review and create tab. If everything is correct, then we are going to create the cluster by pressing create on the left. You can review all the settings one last time, and then we press create. And then the cluster will be created for us. Now the deployment is in progress. This can take a while, so we are going to speed up the video until the deployment is completed. Now that the deployment is complete, we are going to connect to the Kubernetes cluster by pressing connect to cluster. In order to connect to our cluster, we need to type the first two commands here into our Cloud Shell. To open up the Cloud Shell, we are going here above on the right side, and we press this terminal icon. And this will pull up the Cloud CLI for us. Here we want to press create storage. This will take a while. We wait till it is completed. Now we can see the request for a Cloud Shell has succeeded, and we are now connecting to the terminal. First, we are going to set our account and subscription to connect to the cluster. So we copy the first command and we paste it into the Cloud Shell. We press enter. Then we are going to copy the second command to get the credentials. We paste that as well and we press enter. Now to demonstrate that the deployment has succeeded, we copy this part of the third command and we paste it into the Cloud CLI. This should list the default deployments that Kubernetes creates. Let's see if that works, and it does. Now let's go back to our overview window. We go to our home screen. Then we click our cluster. And then we can see the overview of our cluster. And we are going to clear the terminal so we have a fresh screen to work with. Now that we have successfully connected to our cluster, it is time to deploy our first YAML file. Now, what is YAML? YAML is the format that Kubernetes uses to pass configurations. It stands for yet another markup language. And in a YAML file, we can specify the different properties, settings, and configurations that we want to apply to the cluster. For this tutorial, we already created a YAML file, which is available on our GitHub. A link is in the description. It's the first YAML file called one.depl_web.yaml. So we click that file. In the YAML file, we can see different properties, such as the amount of replicas is 1. The name is gymmax. We're going to have to use the same name everywhere. We also are pulling the image from our Docker. It runs on port 80. Now, if we take a look at the resources, we can see that we specified 250 millicores for the CPU, which is the equivalent of 1/4 of one core, because one node has one core and one core is about 1000 millicore. That means that if we have 5 instances of 250 millicores, that will not be possible in one node. So the system would start creating another node. This will all make sense later in a video. Now we are going to copy the content of this YAML file. And then we go back to our Cloud CLI and we create a new YAML file. We do that using nano. We give it the name webdev.yaml and we press enter. Then we paste the contents using Ctrl V. Now we press Ctrl X and then Y to save. We press enter. And now we want to deploy this YAML file. We do that using kubectl. Apply. -f. And then webdev.yaml. And we press enter to deploy. Now we can see that the deployment has been created. In order to check that the pods have been created, we use the command kubectl get pods and we press enter. Now we can see that the pod has been created. Now that the pod has been created, it's still not available for the end user. In order to do that, we need to make it available through a load balancer. Now, to create a load balancer, we need to deploy another YAML file, which we are going to do. But first, we need to clear our screen so that we have a nice, neat interface to work with. So let's go ahead and clear the screen with the command clear. Yes, and now we have a clean interface to work with. Now we are going to deploy the second YAML file for the load balancer to give the pod an external IP. So we move to our GitHub, we select 2.depl_loadb.yaml. The kind is service, the name is service gmax, you can call it whatever you like. The type is a load balancer, the port is 80. The app is gmax because that's what we specified in the previous YAML file, so it needs to be consistent. Now we are going to copy the contents of this YAML file and we move back to our Cloud CLI. We create a new YAML file through nano. And we give it the name gmax-load.yaml. We press enter and then we paste the content. We press Ctrl X, Y and enter. Now we need to deploy this YAML file, which we do using the command kubectl apply -f gmax-load.yaml and we press enter, and then we can see the service has been created. Now if we type the command kubectl get services, we can see that the service gmax has been created and the external IP for the load balancer is pending. When this is completed, we can visit the gmax website through the external IP address. Now, if we repeat the command kubectl get services and we press enter, Then we can see that the load balancer has received an external IP address. Now we are going to copy this IP address and open a new browser tab. And then we paste it into the browser, and as you can see, the website has loaded and is deployed. Let's take a look at the website real quick. Looks like everything deployed as intended. Yep, it is working. Now we go back to our Cloud CLI, and let's clear the screen so we can summarize. So first we started by creating our AKS cluster on Azure. Now let's head over to GitHub. Then we deployed our first YAML file called depl_web.yaml. Using this YAML file, we pulled the image from Docker and created a pod in our cluster. Then it was time to make the pod available to the public. We did that using our second YAML file called depl_loadb.yaml, which is the load balancer, which gave the pod an external IP address, so it was reachable for the public. And now it is time for our third YAML file, which we can use to configure auto-scaling on our cluster. Look at this third YAML file. We can see the kind is horizontal pod autoscaler. The kind is a deployment. The name is Gmax because that's what we specified in the previous YAML file. It has to be consistent. The minimum amount of replicas is 1 and the maximum amount of replicas is 8. We can see that we put the target CPU utilization at 80. This means that every time the CPU utilization on a pod exceeds 80, it will create a new replica for us all the way until 8 are created. Now it's time to deploy this third YAML file. So we copy this YAML file and we move over to our Cloud CLI. Now we create a new YAML file. Let's use nano. We call it autoscale, .yaml, and then we paste the contents. We press Ctrl X, Y, and enter. Now we want to deploy this YAML file, so we are going to do that using kubectl. Apply -f autoscale.yaml, and we press enter. This should create the auto scale service for us. So now we sit back and wait. And the horizontal pod autoscaler has been created. Now that the horizontal pod autoscaler is deployed or created, we can test if this is working using the command kubectl get HPA. HPA of course stands for horizontal pod autoscaler. This shows us some numbers, for instance the targets. Right now we can see that 0% of 80% is being used. The minimum amount of pods is 1, the maximum is 8, just like we specified in the YAML file. Because we are using 0% of our targets, there's only one replica, which means that if you would use all the way up to 80%, another replica would be created. A replica is just another pod. This process will repeat itself all the way until the 8 replicas or 8 pods are reached. Before we continue, let's clear our screen. Then we will simulate traffic using an open source tool called Zeech to demonstrate that autoscaling works. First, we are going to change the target CPU utilization. For demo purposes, we'll be putting it on 1 to demonstrate that autoscaling really works. But in a real AKS cluster, you should not do that. It is recommended that you keep it on 75 to 80% for a real website. So do not change that setting. Now to achieve that, we edit the third YAML file using nano autoscale.yaml. We press enter, and now we scroll down all the way to the CPU utilization percentage, and we put that on 1. We press Ctrl X, Y, enter, and now we need to apply that YAML file. We do that using kubectl, apply -f, and then autoscale.yaml. And then we wait till this completes. Remember, we are doing this just for test purposes. Do not do this on your real cluster. And then we can see that the configuration has been passed. The horizontal pod autoscaler has been configured. To check that, we do kubectl get HPA. And then we can now see that the target CPU utilization is 1%, 0 of 1%. Now let's clear our screen so we have a clear interface to work with. Press enter. Now let's look at our nodes and see how these react. In the left window, we check node pools. We go to nodes, and now we can see the 2 nodes that are created. Now let's see the resource utilization on the screen using kubectl get HPA -w to make it stick. Now we can see the target CPU utilization is on 1% because that's what we specified when we edited the nano file. Now we are going to simulate users by stress testing the website using Siege. So we pull up Siege. You don't have to do this. This is just to show that the autoscaling works. So we give the command siege-b-c 240-t for 300 seconds, and then the IP address, arrow to the right, /dev/null. Then we press enter. So now the server is under Siege. If everything goes well, we should see an increase in the target CPU after a while. This would also cause the amount of replicas to increase. Because right now we're at 1, but after we send the traffic, it should become more. Let's say 2 or 3, depending on how much traffic we are sending. Now let's speed up the video until we see results. Now, if we take a look at the command line, we can see that something has changed. You can see the targets have gone up and another replica or pod has been created. So this indicates autoscaling is working. Oh, and now we can see another set of replicas have been created. So that indicates that autoscaling really works. Now we are going to use a different command to check which pods run on which node. So we use kubectl get pods -o wide. And now we can see 4 pods are running on the first node and 2 pods are running on the second node. We can see that by the names VMS 0000 and 000004. So autoscaling works. Now we go back to the previous command, kubectl get HPA-w, and now we see the 6 replicas. So in short, we've had it for this tutorial. To summarize what we did, first we created the Kubernetes cluster. Then we deployed our first YAML file to deploy the website, to pull the image from Docker. Then we made those pods that we deployed from the Docker image available using a load balancer, which was the second YAML file. And using our third YAML file, we configured autoscaling. After that, we stress tested the website to simulate traffic, which you can see on screen. And that was it for this tutorial. We hope you find it useful and that you learned something. And we want to thank you for watching.